Okay, a good morning to everyone. And it is a Friday morning, end of week 3. Just want you to know, 15 weeks in the semester, so that's 1/5 of the semester. That's a fraction which can be converted to 0.2, which is 20%. Couldn't pass that up. Okay, Debbie, who were we listening to and what was the name of it?
Rolling Stones, Can't You Hear Me Knocking?
Those early sounds of the Rolling Stones just don't sound like I think they should. Can't you hear me knocking? Okay. That's what happens when people knock at the office door saying, I want help. Can't you hear me knocking? Ooh. We've got a problem on the board courtesy of Sandra. And this is one from the computer. This was the first question. We're going to start with 2-5. So we're going to deal with order of operations first. Tabitha, you said you had a couple questions from there. So that material on 2-5, as far as problems in the text, is a 139, 140. And just a reminder, because the question came up, there are a couple of questions that have come up. The problems that we cover on a Thursday are not due until the following Monday. Okay, so this is something that helps to work on it during the day, but it will allow you up through class time on Monday to get them entered. And I did reopen 160 on last night, so I think you wanted to finish up some problems there. So that's been done. And the problem I have on the board, Debbie, as we go to that, is going to be an absolute value with some things inside. And I crowded that 2 next to the parentheses rather badly. But if we talk about things being close together, saying multiply, I can't get them any closer together than that is. So these two are multiplied together. Now what I think you'd want to show is this, where you'd have the 5, then you put the plus sign. Then I would encourage this, Sandra. Change the subtraction to the addition of the inverse. So that made that 2 a negative 2. Now I have the product of a negative 2 and a negative 9, correct? Okay, so that's going to be inside the absolute value bars. 5 plus the 18. Now that's sort of carrying things to an extreme because you could have just said 23 right out of the gate, but that's where the 23 came from.
Yeah.
Where did you get trapped?
I rewrote it as 5 plus negative 18.
Because...
And then I ended up...
Yeah, I understand, exactly. Then you have a negative number inside. The problem might have been helped had you done the rewrite here. Now, if you say 5 minus 2 times minus 9, that could be written just as 5 plus 18. That's probably the way I would have approached it if I weren't trying to emphasize that subtraction means the addition of the inverse. That prevents the mistake. Michael?
No matter what that problem, or any problem that you want the absolute value over, it's going to be a positive integer, right?
Right.
Okay. Well, I was asking, no matter what you do, if you take the absolute value, you should get a positive integer in this case. And I agree. But be cautious, because then we get to this. If I tell you that a is less than 0, and then I ask you, tell me about this. That's supposed to be an a there. What is your answer?
A.
Okay, I don't like the word digit there because a negative a. Negative a turns out to be a positive number because a was a negative number.
Say that one more time.
Negative a turns out to be a positive a because
No, negative a turns out to be a positive number.
becomes absolute value.
This didn't go over any better than it did earlier. Let's see if I can do it this way. Okay, there's the number line with 0, correct? Now I'm saying I have a over here. Now that tells you a is less than 0, does it not?
Yes.
So if a is less than 0, where do you place the inverse of a? You flip it, right? It just comes over to here. Now how do you write the inverse of a? Minus a. Where is it? On the right side. So minus a is a positive. So minus a is greater than 0.
When you're using the letters, it's to the right, it's negative?
Yes. If I take the negative of the letter and the letter was to the left, the inverse of that letter puts it on the right.
That brings it back to the A.
Well, it brings it back to minus a, but it's on the positive side. So this is a positive. How do you write that you have a positive? By saying it's greater than 0. Okay, let me come back center for a moment. Hold on. I understand the confusion. And it may be there for another few weeks. At the end of the semester, I want that resolved. Okay, it's not something I expect to feel comfortable today. If you feel comfortable with it and you understand it, that is fantastic. By the time you take algebra, I demand it. In pre-algebra, I want it. In algebra, you must have it and be able to feel comfortable with it. Work on it. Maybe 3 weeks from now, 4 weeks from now, you come back to that, and I'll keep coming back to it, so reminding you. And at some point you'll say, oh, yeah, got it. It just takes sometimes that long. But it is a very important part. If somebody comes to me and says, I'd like to take algebra, I'll give them this problem. And if they've got it, I'll say, hey, I think that may make it. If they say, don't understand that at all, I say, you probably don't want to take algebra yet. That's my little, those Reader Digest quizzes. Answer these 3 questions and it tells you about your mental health, or it tells you something else.
Your IQ.
Yeah, those kinds of things. This is, are you ready for algebra?
So would negative b be to the right of negative a?
Not necessarily. It depends. It could. It certainly could. So, for example, let's come to, Dion's got a good question. Let's come back to the board now. Let's say over here I have the letter B. Now, B is less than A because it is to the left of A. That's why I don't like this idea of which is bigger in terms of a number and absolute value, because you have no way of knowing that about B and A if I don't tell you what they represent. But if I say B is to the left of A, now, where is minus B going to be? Okay, I'm not drawing these rainbows very well. But here's minus B. And sure enough, as you said, minus B is more than, it's to the right of negative A. So minus B is greater than minus A, and both of them are positive. Now, Dion's question just did for me what I would have, I think, probably not have done as well in what I'm now going to say. Example. Now, hold on. No. Give me a moment here. Let's say I tell you this, that 3x is equal to 15. What did we say you could do to solve that? You have a related equation, right? We said you say x equals 15. This is the way the book's doing it. Right? But it's not the way we did it the other day. What did we do? Ah? Not add. Multiply. Remember what Richie said? The ghost of Richie? Yes, the reciprocal. I multiply by the reciprocal of 3 on both sides. So that's what gave me x is equal to 5. Better than this. Or you can say divide both. One more time. I got frowns on that one. Divide both sides by 3. And you get x equals 5. If you don't like the word reciprocal, I'll blame Richie in that also, since he's not here today. You can tell him I talked about him. Now, I can multiply or divide an equation both sides and the equal sign still holds. One more time. If A is equal to B, A over C equals B over C. This is another one of those that you have to put in your memory bank. If A equals B, you divide both sides by C, you need to get a bigger hard drive. Okay, so if this memory's full, just get a larger one. You're going to divide both sides by C, and it's still equal. And it doesn't matter if you divide by a positive or a negative. We sometimes say, if A equals B, AC equals BC. Multiply both sides by the same thing, and it'll still be equal. Now, courtesy of Dion, and this is good. I like this. I really like this. If you have B less than A, now Debbie, what I have to do, are you in 2 now? 2. Would you go to 1 so we can flip back and forth where 1 is that right over there? So I can have people watching the 2. Now we said if B was less than A, we went ahead and said if you took minus B, it would be now to the right of minus A. This is like, Dion, multiplying both sides here by negative 1. If you had negative 1 times B, you'd have negative B, correct? Nod. Negative 1 times B is negative B. Negative 1 times A is negative A. But what happened to the inequality? What happened to the inequality? It reversed. That's critical. What Dion did was give me a general statement that makes these statements, coming back to this side now, see, this was a statement about equality. There's a thing called duality. Duality means if I can do it for one thing, there's sort of a mirror over here doing the same thing with another. So if I have A equals B and I write instead A less than B, then I'd like a statement like this, that AC is less than BC. I'd like this to be true, just like this was. Duality. Analogous. It only works if C is positive. If A is less than B, AC is greater than BC if C is negative. And that's what Dion gave me. Before I answer your question, back to the other lens. B was less than A, and you saw, answering Dion's question, that by taking B to the left of A and then taking the inverse of B, I jumped across. I took the inverse of A, jumped across, and suddenly the minus B is to the right of minus A. This says that if B is less than A, minus B is greater than minus A. If I multiply both sides by a negative, I switch from less than to greater than to do it. Thank you, Dion. That was good. You just did another section in the book. You did it well. It's coming up. Okay, now your question. I hope we can do something else with your question.
Well, before I ask this question, I want to know that symbol, right? You know how you wrote AC?
Okay, back to here.
AC, is that...
A times C. That means you multiply.
Huh?
That means you're multiplying.
Okay, so A times C, is that greater? That signs greater than, right?
That's less than, left of.
Less than?
Left of, it's like you are in a car,
so AC is
left signal, The arrow's going that way, correct?
Okay, so A times C is to the left of BC, right?
Yes.
Okay, so would BC be negative? Would that be the...
It could be.
Well, if it's greater than...
Wait a minute now. You're doing good with your questions. You just keep asking. Let me try to answer your question first. Negative 3 is to the left of negative 1, correct? And they're both negative. Now I'm going to multiply by a positive number, 2. So I'm going to say 2 times negative 3, and I'm asking, is it still true that that is to the left of 2 times negative 1? Is negative 6 to the left of negative 2? Yes, it is. Still works. It's not whether these are negatives, it's whether you multiply by a negative number. Watch what happens. Start here. Now I want to take negative 1 times negative 3 and negative... Oh. Hold on, Debbie. Just stay where you are. After Liliana does such a neat job, and then I screw it up. But let's see if I can get a little more space here. Negative 1 times negative 3. And here I have negative 1 times negative 1. This becomes what here? 3, right? And this becomes 1. Now, is 3 to the left of 1 or to the right of 1? To the right of, hence greater than. So notice I started with a left of and went to a right of because I multiplied by a negative number. Either multiplied or divided by a negative number, you flip the inequality symbol. So you go from a left turn to a right turn, or a right turn to a left turn. That is a whole section right in its own. And if you get that out of Dion's question, it was worth being here. Even if you played hoops and you're tired, even if you got up late, you had to walk 5 miles in the cold, it's worth it today. Yes, barefoot, uphill, both ways. This is worth it today. Nice question. Beautifully asked. Sandra.
So the inequality will only, or what is that called? That little
Inequality.
Okay.
The less than, the greater thans are inequalities, meaning
Okay.
not equal.
Okay, so the inequality will only switch its direction if it's multiplied or divided by a negative.
Yes, that's correct. And what Sandra said, the inequality is only switched if you multiply or divide by a negative. And if you can keep that in your head for the next 20 years, that's good. But that's how long you want.
But you told us we can...
The inverse of the number, then it switched.
Well, coming back to here again. Remember, the inverse is like multiplying by negative 1.
Oh.
That's why it worked. Hold it, wait. James, are you just stretching? Okay, Dion.
Can you tell us, like, long as if we count the number, like, I mean, not the number, but you know how you have...
The distance from the center, yes, that'll work.
That's how we would know what side it's on or whether...
Well, you know whether it's bigger or not. It's bigger is a bad way of thinking about it. Left or right. Tony the Tiger time. Greater, right of. Less than, left of. The L's for left, the R's for right. Michael.
I was taught, I forget what grade it was, if you, the symbol greater than, less than, if you picture one of them as like a mouth of an alligator,
Yes.
eating the bigger number.
Yes, that works.
That's what I think.
I'm not going there.
Yeah.
Okay, alligators and fish, it's just
You're in college
too
now.
gross this morning. I can't picture an alligator eating a fish while I'm drinking my coffee. It just doesn't work for me this morning. But it's another way of looking at it. I agree. Now, we had other questions. So Dion, thank you.
I don't even know what I did, man.
But you did well. I couldn't have sat on site and said, Dion, ask these questions. This is as good as it gets. No, you're not confused. It's just new and you're uncomfortable. There's a difference. Okay, before I go to Tabitha's question, one more shot.
Yeah. So does that everything you just did right there?
I'll get
is
back
that
to
all
here.
Switching,
All this, everything, garbage, switching.
right?
Okay.
That applies exactly to that little graph thing.
Little graph thing. back to here.
Like, is it the same
Yes,
thing?
this is the same thing. It's just here we started out asking if B was to the left of A, B was less than A. Dion was asking, wouldn't that mean minus B is to the right of minus A? And the answer is yes. And I said, but wait a minute. Those are inverses. How can I get inverses? That's minus 1 times this, minus 1 times this. A switch went off of my head, and I said, a golden opportunity to talk about inequality. Nicely done. We make a good team. What? I don't know where it is. It's somewhere in the book. It's coming. Now, I'm going to migrate over there, I think, because I've pretty much filled up this board. And Tabitha, is there a general question, a problem number, before I leave the document cam? So I'm not sure what I'm going to be doing. From the computer? Okay. So I guess the best thing to, again, remind people as I just come up this far, I'll go to the document cam. So just to remember, this is where we are for those of you watching on the 3C Media Solutions Network from Palomar. Brian got some advertisement free there. Okay. Now, Tabitha, would you read me the problem?
Okay,
Negative 3.
absolute value sign.
Right next to it?
Yeah.
Okay.
34
34
divided by 17
divided by 17
minus 3
minus 3
times 5.
dot 5.
Yeah. And then absolute value sign.
So that's it.
Yeah.
Okay. Tabitha, could you reach that eraser and throw it at me gently? Thank you. Nicely done. Okay, I need to make that absolute value sign. Now see, that's real trust when you ask somebody to throw something at you and you don't duck. Okay? Now, the question, what do I do first? Go inside the bars. Now, that's different than a brace, a bracket, a parentheses, but it's still a grouping that's provided. So in the bars. So we go inside the bar, and now what do I follow? Order of operation. So I'm going to do multiplications and divisions in order given first. So what's the first thing I see?
17 and the 34?
Yes, the division here, so I'll replace that by a 2. Then a minus sign, and it says multiplication. That's the next thing I saw. I have just, for the moment, forget about the negatives and the positives. So that's going to be a 15. That would be my first step. Now, I don't know if this next one's necessary. I mean, the text is expecting you to do what?
Right, minus 3, then do that.
No. Change this to a what? Plus the negative 15. And then go ahead and do the addition. And that then is going to give you negative 3 times the absolute value of negative 13. And if you say, hey, I don't have to do that. I can do that in my head. Good. But if you're having trouble with it, then do it for a while. Because you do have to get to the point where you're running through problems a lot faster. If you slow down too much, then you don't make the progress. It's a little bit like when you first start driving and you're out in the freeway and there are about 5 lanes of traffic, the hands have a death grip on the wheel, right? You're holding on for your dear life. 3 months later, same, one hand in the steering wheel, okay, just relaxed. That's the difference. Right now, you may not feel relaxed. Now, what is the absolute value of negative 13?
13.
Just 13. So this means I have negative 3 times 13. And again, and if I'm blocking you, look at the camera. Well, the absolute value of negative 13 is 13. It is technically, I can't pass this up. Note, I told you I'd keep coming back. The absolute value of A, if A is less than 0, is what? We said? Negative A. Okay, so I have the absolute value of negative 13. So this is A. So what is that going to be? Minus a minus 13, which is the additive inverse of the additive inverse, which is 13. let me finish this part here. Okay, and then I'll answer your question, Robert. What is negative 3 times 13? Negative 39, right? Now, Robert, question. Here?
Yeah. Why did you change that to a negative number instead of just doing that?
A minus B is interpreted as what?
A plus negative B.
A plus negative B. We don't have subtraction. We add the additive inverse. We traded in for an addition. Okay. That was when you were back here near the door. Okay, that time. We trade in a subtraction for an addition, because in algebra, we're really saying there are two operations: addition and multiplication. If you want to do subtraction, add the inverse. If you want to divide, multiply by Ritchie's reciprocal. Doesn't that have a kind of alliteration to it? Ritchie's reciprocal? Sounds like the name of a restaurant. Ritchie's reciprocal. Sandra.
I have a question about the absolute value. I remember us before discussing that anything that said absolute, well, not anything, but any number, I would say, and said absolute value would always end up a positive.
Yes, okay, what Sandra's saying. When you take an absolute value, you're supposed to get a positive. I did.
Unless there's a negative sign on the answer.
Because A is less than 0. Okay, Debbie, back to Dion's diagram. Looks like a turtle going in two directions at the same time.
Sounds like a doctor's office.
Oh, okay. Let's go back to that. Okay, now, keep in mind, this helps. This diagram is supposed to help. A is to the left of 0. It is negative. Minus A is over here. Isn't that positive? So don't I have minus A as positive? Back to the other board. So, there. So if I come over to here and I talk about minus A, because A was on the left side of 0, minus A is positive. See, this is your misleading cue. You see the negative sign and you say, got to be a negative. No.
So, like...
Silence, everybody. I think she's coming.
No. So, but A could also mean, like, a negative number, so if you times that together, it ends up a positive.
Yes!
Oh, I see.
Ah, yes! One victory.
I get it.
Okay. Explain it to everybody else who doesn't later.
Okay.
Now, that's the way you'll keep it, once you got it. Tabitha, does that answer your question? And hopefully it didn't raise any others that you don't have answered. Okay, you said you had another one. Could you do the new one, like, you think, doing what we did here? Okay, do you have any others you want to ask? Okay, so we took care of a question for Sandra. We answered Dion's question and created a whole new section of material. We answered Tabitha's question. Robert had a question that allowed us to come back and do this again, reminding you that we trade subtractions for additions. Gee, didn't we hear that before, called the Austrian method? A groan from Emily. The Austrian method was just this, in essence. Trade a subtraction for addition. Don't take things away. It's immoral. Okay, other questions? What now?
No, I think that it's a good thing.
Okay, now we've been talking about you for the last half hour. We've got a name for a restaurant for you. Ritchie's Reciprocal. We've been talking about it. And Debbie said we did what? Serve only desserts?
No, dessert first, because that's the
Desserts first, the inverse. I like that. So we've got a whole new thing for you. You can just walk through there. Okay? So the idea being that if you have the inverse, it's sort of the other side. So you think of the menu, dinner, then dessert. So Debbie's right. Dessert first, then dinner. My grandkids would love it. Good idea. What was that comment, James?
You eat dessert first before you did it, you don't eat as much.
There you go. If you get dessert first, you don't eat as much dinner, therefore it saves food.
I do.
That's what's so good about it.
There we go. Now, more questions. Okay, Tabitha. New question. Bracket.
39.
39. Minus 2. Parentheses. Negative 3. Now see, you could be saying open parentheses and close parentheses for me to help me, but that's okay. Next, close bracket, divided by, open bracket, you're getting good. Open parentheses, 20, minus 8, close parentheses, plus, good grief, open parentheses, negative 3, close parentheses, thank you. Plus, this is not fair. Open parentheses, 8 minus 3. You got this off the computer.
Did you have your Wheaties this morning?
Boy, but she said it well. She said it well. So if you're on the phone and you're talking about problems, you have to say it like Tabitha did. Okay, I would go bracket, simplify those, just the brackets first, because groups first, right?
Yeah.
Now, technically, exponents come after the radicals, so I do the groupings and then the exponent. So while we're at it, this would be 5 to the 4th, correct? Yeah. Which we would have as 625. You knew that. Okay, so we got that out of the way. Okay, back to this bracket. Go to the inside. Well, the inside the parentheses is really a multiplication, understood. So what is the key here, Robert? What? What I was hoping you would see is that you would have this and rewrite it as a what? Addition, which was your earlier question. Okay, so you're comfortable with that. Okay, so that's going to be 39 plus 6, also known as 45. So notice how I'm parsing it out, piece by piece. I think it's a little bit like the pyramid structure we did earlier. Okay, so I've got a division sign after this in each case, so that hasn't changed. New bracket. Okay, so in here, I can't pass up doing this, even though you know 20 minus 8 is 12 and you're there immediately, correct? Yes. But that's no fun. 20 plus a negative 8, parentheses, plus minus 3, you could apply what property? Okay, but what property? No, not the distributive. Not the commutative. The associative. Grouped here, shift the grouping here, and do what Jessica said. The negative 8 and negative 3 is negative 11. Again, I'm going to do the negatives together. I switch it, and this becomes my new parentheses. I shifted it over. That's the associative property. May I remind you that A plus B plus C is equal to parentheses B plus C. That was a property that you didn't write. Now, okay, so I could say this is just 20 plus negative 11, which is 9. You did write it. Let me see.
Look, I wrote it.
Let me see.
I wrote it. I moved my parentheses around. Uh-huh.
You reverse some things at the same time. You aren't supposed to reverse the A, B, and C. You provided an associative tied together with a community property, and we call that assumptive. And it isn't a property. Now what are we going to do? We are going to do what first? Divide first, multiplications and divisions in order before the additions and subtractions. So 45 divided by 9? 5. Added to 625. 6:30. And I was going to see what time it was. It's off a few hours. Okay, so 6:30 is our answer. Okay? That was a fun problem.
They're not as fun when we're sitting in front of the computer by ourselves.
No, a good point. Okay, good point. They're not as much fun by your lonesome.
Right.
What have I told you? No, work together. Work, well, a little bit different. If you work with 2 or 3 people together, you can have fun, you can laugh, you can help each other, and you get through them without the pain.
They discourage laughing in the computer labs.
Well, but you do it at maybe the student center, around a table over lunch. You can now go to lunch together, and you can do it.
But I said go to tutoring. Isn't that the additive inverse of what you said? I'm just saying, though.
Dion is going to tutoring, the additive inverse of going to lunch.
No, you said working together. Going to lunch, working together.
Now, you wouldn't say additive inverse. You would say analogous to. Duality. Ah, but I said duality. See, that is the duality of working together, going to. But you gain a little and lose a little. If you go to where tutoring is, there's help when you don't get as much out of the help as if you're working together discovering it for yourself. There's a difference. And it's a very critical difference. If somebody tells you how to do something, you don't get as much out of it as you do working it through on your own and arguing with each other and trying to defend yourself. Huge, huge difference. Well, it's positive, but it's a big difference. And one of the greatest difficulties in the whole tutoring concept, I get help from tutoring, I know the material. No. You get help from tutoring so you can do the problems. You know the material when you tutor somebody else, when you explain it to somebody else. And so if we have somebody coming up to us in a non-bridge class and they say, I need help, I want tutoring, and we can sign them up for 2 hours, 3 hours a week tutoring. The caveat to that is, the sort of other part of it, is you do work after the tutoring, doing your homework yourself. The tutoring is not replacing that effort you make on your own. You have to explain it. You have to do it. And it's like preparing for a test. I say redo the problems. Push the pencil through the problems. Because if you just look at your homework or somebody tells you how to do it, it is not the same. And that's just not in homework. That's not just in terms of doing problems. You name anything. You sit in a car and you watch somebody go from here to another city. You're paying attention. Now you get in the car and try to do it on your own. Very often, you get lost. So, James, you've got a problem. Okay, you woke up finally. You're into it now. Okay, moving down a little bit further. Okay, go with it, James.
-3.
-3.
Braces.
Braces. Races. Okay, braces.
14.
Four-
-2.
14.
-2.
-2.
Absolute value line. 20 -7.
Okay.
Parentheses.
Still parentheses. Open parentheses.
4.
4.
Close parentheses. Absolute value line. Braces. Close braces.
Okay.
Plus. Bracket.
Okay.
Open parenthesis 3.
Okay.
Close. Open parenthesis. -9. Close. Minus. Open parenthesis.
You better be done pretty soon. I'm running out of room.
-21. Close parenthesis. Bracket. 2 to the
Exponent?
quantity.
That whole thing to the second power.
Yeah.
Well, you got done just in time because I was out of board. Okay. Now, what are you going to do first?
Start with
The braces in front, right? Because I can't do anything with the negative 3 until I go to the grouping inside. But inside, I've got to go to what? Here. Because that has to be done before I can do what? Change this to the addition of the inverse. So let me rewrite some things here. I'm leaving that negative 3 out front. The brace is there. The 14 plus a negative 2. And then here, I still have 20 plus negative 7 times 4. Now that I'm doing for clarity. I would have done a little less than, I'll rephrase it. I would have done more on my own if I wasn't trying to show you. I could do the distributive property, but the problem is this isn't a parentheses. It's an absolute value. So I can't bring that in. I could write something that would make it work, but I don't want to go there. So let's stay away from a distributive property for the moment. So 14 plus, then a negative 2, and this is going to be 20 plus negative 28, correct? This is a negative 28 added to the 20. I don't do the subtraction first. Okay, so this is the absolute value of 20 minus 28. Still having fun. So this is negative 3. 14 plus the negative 2. I don't know. Okay, I'm having real trouble wanting to go one more step. But this is negative 8 at this point, correct? And so the absolute value of negative 8 is 8. So I could do that, or you could write the whole step. Otherwise, the absolute value of negative 8. Can I take that shortcut?
Yes, isn't it?
Okay. Didn't want to wake you up. Now, negative 3, brace 14, plus negative 16. Now, we could, at this point, do Emily's distributive property. I could take negative 3 times this and add it to negative 3 times this, or why not just say negative 3 times negative 2, which is 6. Okay, we got that part. Plus. That mess. Okay, so we've got a plus now. Inside the brackets. Well, I do multiplications first, so that's sort of nice. That's negative 27 right out of the gate. Plus an inverse of negative 21, which is negative 27 plus 21, which is negative 6 to the second, which is 36. So a plus sign, plus sign, plus sign. I have a 6 added to 36, my answer. Now, we might have done fewer steps. The key, find a balance. I mean, you don't want to bury yourself in these, and you can easily bury yourself with the steps. But do enough that you don't make silly mistakes. And if you find yourself making silly mistakes, back it up, show more work. Does that answer your question, James? Where did you get that problem? It's like number what? Number 70. So let me slide over and just identify this. So people who have the book, this was from the computer 70? From the text. Okay, good. So this is a text, T-E-X-T 70, as opposed to a computer. That's not readable at all. Okay, so if I call that number 70T, or T70, there we go. Number T70, meaning in the text. And if it's C70, it's computer. Okay, let's slide over. You got a question. Okay, where did this one come from, Tabitha? Computer what? Computer 20. And Tabitha, where did this one come from as we slide over? Number C15. So again, the comment, if you're doing the computerized homework, that's not the same problem you did. But it gives you another one to look at. Okay, Soshi, you have a question. Okay, so a short question means I just need to find a little space, right? This will do it right here? Okay, so this is, well, that's for another question. Okay, so I've got a new question here. We blocked off the territory for you. A little bit louder.
Negative parentheses,
Negative parentheses.
negative 2,
Negative 2. Close parentheses. And a 4 up here? Ah, yes.
No, but I had a question because it's bad to not be negative, but I was saying don't you use a negative as a positive?
Okay, I understand your question. Now, what Soshi's asking, can't I just bring this negative through right away and get a positive and take it to the fourth power? Exponents first. What's not here that you aren't seeing? The unseen 1. It's really like negative 1. That's how we did the negative a was like negative 1 times a. So that is the same as, if that'll help, what comes first? Multiplication or exponents? The exponent. So that says the exponent is what? Attached to whatever's there. That was a negative 2. That's negative 2 times negative 2 times negative 2 times negative 2, which is an even number of negatives, therefore positive 16. But I still have out in front what? Either the inverse of that or the negative 1. And now I multiply and hence the negative 16.
Well, you can easily just, because you see the negative sign on the outside of the parentheses, you can just bring it towards, to the 16 instead of just like...
Rather than seeing it as a negative 1? Is what? Yeah, I agree. If you see the negative sign out in front of the 16, then it's the inverse of the 16, which is negative 16. I think the problem here was realizing that you had to do the exponent first and understanding that negative sign was like a multiplication. That would be the misleading cue. And I think that's what Soshi was asking. Sandra.
Can you do like another very small problem just with that part up there where the
That part up there, okay. Can you give me an idea where up there
where
is?
that, the brackets where you have the big
Like
parentheses.
this one?
No, the one to the right.
Okay.
20
Yeah,
plus
right.
negative 8
This one?
down. Yeah, down.
There?
Yeah, there.
Okay, we're here.
Where
Now,
you instead of doing 20
oh, you didn't like the associative property here.
exactly, and I'm going to get confused with that because
Okay, well, just a minute. I understand your question. If you don't like the associativity and you have such a bias against the associativity property,
Well,
just giving you a bad time, then you could say 20 minus 8 is 12, and 12 minus 3 is 9.
so it'd give you the same answer.
Yes, it would.
Okay, that's what I was worried about.
But
I was worried-
associativity is a good property.
Yeah, so can you give me another one so I can get used to it?
Not yet.
Okay.
I'm watching the time. Okay, other questions in this space I have here that I can still answer. Another question from 2.5. And notice, 2.5 is pushing you a lot harder than 2.1, 2.2, 2.3, 2.4. And the reason I bring that up, the quiz today is on 2.1, 2.2, 2.3, and 2.4.
Thank God.
Well, yes. I mean, an oh Lord and thank God at the same time. And they were, one was a plea and one was a statement of thanks. Now, it's nice because those were much easier. Everything we've done here is based on knowing what to do from 2.1, 2.2, 2.3, 2.4. Pareto's principle. Back to the 20-80 rule. What's the danger? This is be forewarned. 20-80 rule. Pareto. 20-80. Pareto. It says 20% of the fishermen catch 80% of the fish. 20% of the production process is responsible for 80% of the defectives that you have in a production process. 1 out of 5. When you prepare for a test with 5 things, the danger is to take one of the 5, 20%, and spend 80% of your time on that one thing when there's only going to be one problem on the test, like that. and the other simpler ones you failed to redo and then make silly mistakes on a test, losing points. We have 5 sections. Where has all of our focus been so far? One section, number 5, which doesn't happen to be on the quiz. The danger is we just spent 80% of our time on what? What you aren't quizzed on today, which I think this will help the homework. But the quiz I'm concerned about. So let's slide over to Soshi's problem. Because her problem is from 2-1, 2-2, 2-3, 2-4, which is what you're going to be quizzed on. That was an important problem. For relative to your quiz, more important than everything else we've done. So will you do the following for me? Will you now take a moment to look at 2-1, the problems, 2-2, 2-3, and 2-4. Just look at those sections. And I'm going to ask you something I just asked the Math 10 group to do, which was, if you were to select a problem from a test they just took, and you were wanting it to represent the test, what problem would you choose? And I asked them to choose 3 or 4 out of 10. If you were to look at the text, 2-1, then 2-2, 3, and 4, what 4 problems, one from each, would you select? Just as a typical problem that you were to write a quiz for somebody sitting next to you, and that would be their quiz for the day. Since I have the quiz written up today already, I don't want to do that, but it does suggest to me a very nice thing to do in the future. Not come in with the quiz, and the last 10 minutes, you pick 4 problems from 4 sections, and then you give it to your neighbor, and that's their quiz for the day. Be careful who you sit next to. If it's a friend, it's good. If it's an enemy, they may not be so kind. If you just ruffled their feathers, you might pay for it. Look at 2-1, 2-2, 2-3, and 2-4. And see if there's something, and you don't want the hardest problem. And I want you to look at the problems, not the examples, the exercise. Look at the exercises, and the question is there something there? And don't hunt for the hardest nor the easiest. If you look at a mainstream problem, mid-range, open your book. Look at the problems in the book. 2-1, 2-2, 2-3, and 2-4. I will get you with that book open yet. No, I want you to look at the problems and see if there's anything mid-range that you look at and say, wow, I'm not ready for that. That's the question. Okay, but not the hardest problems, not the word problems. Looking at the kinds of problems like we've been focused on here, but in 2-1, 2-2, 2-3, 2-4. What I'm covering now isn't how to do a problem, it's how to prepare for a quiz. How to prepare for an exam. And not get trapped by Pareto. Who was an economist, by the way. And he was talking about the distribution of wealth. 20% of the population has what? 80% of the wealth. Okay, Michael. Okay, give me the problem.
It's out of 2-3. -4.
2-3 is our section, okay. And what is it?
-4.
-4.
Minus. Open parentheses.
Open parentheses.
Minus 19.
Minus 19.
Close parentheses.
That's it?
Yep.
That's a good problem. Now notice, that isn't nearly as bad as the garbage we've been doing. Right? Okay, I'm watching, Debbie. Now, here I'm going to have -4 plus the additive inverse of -19. That was for Robert. Look at the camera if you can't see. And so, yes, that's going to be -4 plus 19. And I hope you see that and say, well, that's 15. Is this about the time, Debbie, or give me another minute? 1 minute. Well, I have 1 minute more. So, how could you do this? I can't pass this up now, just from an earlier moment. You could say that is equal to -4 plus 4 plus 15, because I broke what? the 19 into 15 plus 4, and now negative 4 plus 4 is 0 because it is the inverse property, giving me the identity, and 0 plus 15 gives me the 15 for the answer. No, I'm not taking off points. I'm just trying to remind you of something we said earlier, how you can treat subtraction as an addition of an inverse. Okay, I'm not going to push this any further. I've got about 30 seconds to bring this down. I don't want Brian panicking and Debbie getting in trouble and I get in trouble and so on. So we're finishing up this morning. We're going to have a very short quiz. And what is your choice as we close down with music? With